Okay, so this is assignment 4.5 about quantitative data analysis. Quantitative data analysis techniques. Quantitative data analysis is a way of collecting and analysing data that has been conducted on a large sample of people. The way quantitative data differs from qualitative data, though, is the fact that the results won't be in detail and include people's personal feelings and emotions towards a particular topic, as it will be brief and just categorising them according to what they think, so there isn't much insight into their reasoning. However, it can be useful, as if you have a sample of young sports athletes all around the same ability, you can compare their results and make predictions on what other people around their age will get in that particular test. Data organisation. Organising data is a process where you put data you have collected into formats and sets to make it easier to understand and analyse. 3 ways of organising data is finding the range of your data, putting it into rank order, or simple frequency distribution. Finding the range of a set of data is where you subtract the smallest figure from your set of data from the largest. This allows you to find the difference in your data set to find out how similar people's results are in that particular subject. However, it doesn't give much more insight than that. For example, most people's results in the dataset might be fairly similar and have similar patterns in the differences in scores, but then if there is one person who is miles worse or miles better than everyone else, then it will increase the range, and you could class it as an anomaly within the results. However, we won't know this, as we will just be given the figure of the range. In this example, you can see on the screen the range of clean sheets per season would be 9. The range of the average saves per match would be 13, as you're minusing the smallest from the largest. Rank order distribution. This is a way of organising data where you just put your results in a rank order from biggest to smallest. This is useful when collecting data, as especially when conducting quantitative data analysis, you are likely to have a medium amount of results. It is a simple and quick way of organising it, and it will be easier to read and therefore analyse it in order in comparison to if it is a load of random numbers in a random order. An example of this type of organisational method can be put into practice is shown on the screen. Simple frequency distribution. If you use simple frequency distribution to organise your data, so using simple frequency distribution is basically where your results are displayed in a table, and this will make it a lot easier to read and understand, and in some cases may reduce the amount of results you have. This might be the case as the point of simple frequency distribution is that you make a table and one column will contain a list of the different results. There will also be another column with a tally of the amount of times this figure occurs from different participants, and then there will also be another column with the number of the amount of tallies when different athletes have the same results. Finally, there will be a column with a number that represents the difference between each of the previous column when you add them together. Now on to presenting data. There are many different useful ways of being able to present data extracted through different types of tests, and in lots of cases, certain tests results will be shown best in particular types of charts. For example, a test comparing 2 different variables would be best presented in a scatter graph. Now, a scatter graph is what's shown on the screen, and they are very similar to line graphs in that they use horizontal and vertical axes to plot data points. However, they have a very specific purpose. Scatter plots show how much one variable is affected by another, meaning the relationship between 2 variables is called their correlation. There are 2 types of correlation: positive, meaning that as one variable increases, so too does another, or negative, meaning As one variable increases, the other decreases. Another way of presenting data is using a bar chart, which again is shown on the screen. And this is a diagram in which numerical values of variables are represented by the height or length of lines or rectangles of equal width. Bar charts are a type of graph that are used to display and compare the number, frequency, or other measure, like mean, for the different discrete categories of data. The chart is constructed such that the lengths of the different bars are proportional to the size of the category they represent. Now, a line graph has two axes. The x-axis of a line graph shows the occurrences and categories being compared over time, and the y-axis represents the scale, which is a set of numbers that represents the data and is organized into equal intervals. Line graphs are used to track changes over a short and long period of time. The standard deviation bars is a measure that is used to quantify the amount of variation or dispersion of a set of data values. A low standard deviation indicates that the data points tend to be close to the mean. This can also be referred to as the expected value of the set, while a high standard deviation indicates the data points are spread out over a wider range of values. Box plot is a simple way of representing statistical data on a plot in which a rectangle is drawn to represent the second and third quartiles, usually with a vertical line inside to indicate the median value. The lower and upper quartiles are shown as horizontal lines either side of the rectangle. Box plots may also have lines extending vertically from the boxes, which are known as whiskers, indicating variability outside the upper and lower quartiles. A box plot might also have outliers, which are particular results or findings that do not fit the complexion of the results in the box plot and will therefore disrupt the general pattern of the results in the box plot. When you have outliers, there are a few different things you can do to stop them from affecting your box plot. One method is trimming, which is where you simply eliminate the figure from your results so it is not plotted on the box plot, meaning it will no longer skew the dataset you have collected. You can also use a method called Windsorizing, which is where you replace the outlier figure to be the same as the next closest figure to that. This means that you will still have the same amount of figures in your dataset, but there won't be any figures affecting the box plot. A histogram is an accurate representation of the distribution of numerical data. Is an estimate of the proportional probability distribution of a continuous variable. Within the histogram, in order to construct it correctly, you need to get all of your results and divide the entire range of values into a series of intervals, and then count how many values fall into each interval. In my example, the graph shows the frequency of different people's age, so the different intervals shown along the x-axis are the different ages going up in a series of 10. Normal distribution curve. The curve in a normal frequency distribution shows how often an experiment will produce a particular result. The curve is symmetrical and bell-shaped, showing that the trials will usually give a result near the average. A normal distribution curve is useful for showing if you have many independent variables that may be generated by all kinds of distributions, assuming that nothing too crazy happens. The aggregate of those variables will tend towards a normal distribution. Skewed data. When you have information that is not normally distributed, so does not visually resemble a bell shape, the data is described as being skewed. This means that the data, instead of being evenly distributed, is more biased to a higher value or to a lower value. This is where you can then have a negative skew or positive skew depending on which end of the graph your results are tending to be biased towards. Measures of central tendency. Central tendency is a process where a single figure is used to represent all of the data. In this case, you can use the mean, median, or mode. The mode is the value that will occur in a dataset most frequently. The median is the result that reflects the middle value once you've put all the numbers or figures in order of their size, and the mean is what you would get if you add all the figures in the dataset together and then divide them by the number of figures presented to find the average. It is measures of central tendency where you are likely to get outliers, especially when finding the mean and the range, as this is when you have to add all the figures and divide them by the amount, or take the smallest figure away from the biggest figure. So if there is one number bigger or smaller than the others, then this will give the mode or the range a noticeable difference. Inferential statistics. By using the p-value in inferential statistics, it allows you to give more meaning to the data that is collected and allow you to infer meaning into what the results actually show. One way this can be done is by comparing your data with the p-value to find out whether your results are statistically significant or if it might have just been luck. For example, if your results are lower, if your p-value is lower than 0.05, your results are statistically significant. However, if your results are above, then they are not, which would suggest that the increase or decrease in results are just a fluke and due to luck. Dependent t-test. This is a type of test that involves using a group of participants to carry out a test twice, but one of the times there will be some sort of intervention. For example, this may mean doing a 400-meter run twice, but one of the times the participants are given an energy drink. In the case the likelihood is the researcher will be testing if that particular energy drink has an effect on the athlete's speed completing the 400-meter, and will look at all participants' scores from both attempts and then compare the means to make a conclusion about the effect that the energy drink had on the individual participants. Wilcoxon's matched pairs signed ranks. The Wilcoxon signed rank test is a non-parametric statistical hypothesis test used to compare two related samples, matched samples, or repeated measurements on a single sample to assess whether their population mean ranks are different. Mann-Whitney U-test. In statistics, the Mann-Whitney U-test is a non-parametric test of the null hypothesis that is equally likely that a random selected value from one sample will be less than or greater than a randomly selected value from a second sample. Unlike the t-test, it does not require the assumption of normal distributions. And finally, the chi-squared test. A chi-squared test, also written as an x-squared test, is any statistical hypothesis test where the sampling distribution of the test statistic is a chi-squared distribution when the null hypothesis is true. Without all other qualification, chi-squared tests often is used as a short for Pearson's chi-squared test, which simply means it's a statistical method assessing the goodness of a fit between a set of observed values and those expected theoretically.